you've been have a great day today. So my topic is about modularization, how it speed up your team. But first, let me introduce myself. My name is Minh, and currently I'm working at Gradle Singapore. First, I want to give you some scenario. Let's say that if you are working in a large team or multiple team working in one single project, then every day you and your teammates may add more and more feature to the project. More code means longer build time. Maybe it's not only clean build but incremental to build. And furthermore, the need of separation and decouple your code become a must. At Grab, at our team, we used to have a legacy project, and we face some problems. We have a legacy project with a lot of code coupling. We have multiple teams working in one single project, and the team is growing very fast. So it brings us some red flag for first scalability, secondly like the speed of development, also the stabilities. For the reason, like for the difficulties, we decide to rewrite the whole project, re-architect the project with a suitable architecture, and along with that, we also apply modularization like multi-Gradle module approach, which I think is quite interesting to share with you today. So the content will be, but I'm gonna bring out some difficulties that if you are follow the monolith approach, then maybe you face some difficulties. Secondly, I want to bring out how modularization could improve build time, and the third one would be now it's enforce you to separate decouple your code, so somehow it decouple your code and it will speed up your development. And finally, some experience sharing that I think that it may save you some time if you want to follow this approach, or maybe you already have. So let's go with the monolith difficulties. So for let's say that if you have one Gradle module in your project, it means that all of your class, all of your packages and resources will belong to one single Gradle module. And whenever you do some small change in your project, like you just do small change in one method or in one class, and you hit the build button, then not only that class and method being used, like that bucket being rebuilt, also you also have to rebuild the whole project. It's not really reasonable. Second difficulty that I want to bring out here is about the code availability. Let's say that because all of your class and resources belong to one single Gradle module, so everywhere in your project you can reference to any class that you want, or you can reference to any resource that you want. If you don't have a good strategy for accept modifier. For example, here as you can see, I have a future A bucket and future B bucket, for example. Then now some class supposed to be only being used in future B is being referenced by future A, and maybe some resources being supposed to only be used in future B is being referenced by future A. It's just an example. So because of that problem, then it will lead to code coupling, like some future are colliding. For example, now sometimes you want to do some small change, but it affects the other place, or you want to fix the bug, but it somehow generates some other bug or something like that. And we because we have multiple teams, or maybe you have multiple teams, and let's say if you work in multiple feature, and you're gonna get like maybe some conflicting. Okay, this team working on this feature and read the other feature, and so on. Or maybe many of you know that if you want to do instant app in Android, and you have to follow the multi-Gradle module approach. So for the difficulties, our team decide to follow modularization. And we believe that is a solution for you to improve your build time. And secondly, it's also a solution for you to separate and decoupling your code, and it somehow will speed up your development. So I will focus on these two topics. So first, I want to bring you the so how it actually improve your build time. First, I want to bring here the build process phases. Let's say how do Gradle build your modules. Let's say when you hit the build button and how do Gradle working. It be divided to a few phases that I want to show you here. First, it will be prepare your dependencies. Let's say okay, now Gradle gonna check this module needs some other modules, so Gradle will be for you, or it have to go to Artifactory and download some library. The next phase it will be now Gradle will merge your resources and manifest files. All of your string, image, or manifest file will be merged in this phase. And then the next phase will be compiling. Compiling here also contain, like first it's gonna do annotation processing, and the next step will be combine all of your Java or Kotlin file to bytecode. And the next phase will be prepare for your S files. Let's say maybe you have one single dash file, or if it's multiple dash file, and Gradle have to decide which class gonna belong to the main dash, or class belong to the other dash. The final phase will be packing and publishing. If it's a library module, then Gradle gonna export to AA file, or if it's an application, and then you got the APK file. So let's say if you have only one single Gradle modules, and when you hit the build button, what is the problem? You have to understand that this tasks, build phases have to run in order. You cannot do them in parallel. So maybe your computer have, let's say, your processor have 4 core. Maybe when you hit the build button, only 1 core is being used to build your project. Actually, there are some parallelism within the task it provided, but actually it's limited. But for multiple Gradle modules, you have an option to enable parallel building. It means that you can build the modules parallel. Here's the configuration that you can use. So now if you are using multiple Gradle modules and the modules are not depend on each other, then when you hit the build button, the module can be built in parallel. Let's say maybe your processor have 4 core, 8 core, then you can build like 8 modules at the same time. So it will be significant reduce your build time, especially clean build. So that is about the building process phases. And the other thing is about some dependency configuration that Android looking for Gradle 3.0 providers. That the implementation and API which is being provided to replace for compiling. To understand this, I want to bring in a very simple example. Here you have actually this two projects is the same, almost the same. Only the difference is the dependency configuration. In the left side, I am using API or compile for the dependency configuration. In the right side, I'm using implementation. The first difference here is about the code availability. Here, let's say for example, the module B3, the code in module B3 will be accepted not only in module B2, but also module B1 and application can access to the module in the code in module B3. But for implementation, only the module B2 can access the code in module B3. And the other module cannot access because I have no dependency to module B3. That's the first difference. So now let's say I do some small code change in module B3, like some small code change, and I hit the build button. So when I hit the build button, module B3 is of course will be rebuilt. But for the left side approach, module B2 and module B1 application also have to rebuild. But if you are using implementation, then only module B2 and application being reviewed. For the simple example, maybe it sound not much, right? It's only one module, let me take out the build time. But let's say you have like 50s or 100 Gradle modules, and it will be significant improve your build time for especially for incremental builds. So that may so cool that I'm just saying, but maybe you need some numbers. So I create a sample project. Like I just write some script to generate some class and method. I generate for more than 100,000 methods. I pick more than 10,000 classes and I divide them to 16 buckets. And I create 3 projects from the class. I copy the class and buckets to 3 projects with different approach. The first one I am follow the monolith approach, like only one single Gradle module and put 16 buckets in. The second approach I create 16 Gradle modules and the dependency look like this. And the dependency on using the all dependency using implementation. And one more thing is all of the number of class and method in the module are different. The third approach, like I create the third approach, the dependency look like this. Only like the whole module is not depend on each other. It's only the application depend on the rest of the module, and the number of class in each module are the same. So I do some builds. I destroy build 20 times on my computer for each project. And here the result. For the first approach, it takes 180 seconds, like 180 seconds, about 3 minutes. But for second approach, 16 module and the dependencies is like kind of complicated. It takes 40 seconds. The third one takes 29 seconds. Those are clean views, but for incremental view, it depends on your chain. It depends on like how much of the code that you change and where you change it. So it depends. So what is the conclusion here? The conclusion here, I want to say that how your dependency tree look like, and the how many methods and class in each module will design your build time. So I already published this project to GitHub. So if you want to play around to see how multi-Gradle module can improve your build time, you can check it out and play around with that. Yeah. So that is all about the build time. Secondly, I want to talk about how multi-Gradle module and forbid to separating and keyboard your code. But I have to admit that okay, separating and decouplable should be your architectural responsibilities. But multiple Gradle module should give you a good hand for it. So modularization, it means that you have to break down your code base to multiple modules along with the limitation of code accessing. Let's get back to the monolith approach, right? So in monolith approach, every class, every resource can be accessed from everywhere. But now for modularization approach, you cannot have the access if you don't put the dependencies. And now because of the build time, like if you want to build your module in parallel, you have to you cannot put them in dependence. And now you must have a real reason to create a dependency between two modules. Otherwise, if you put dependency everywhere, then you're gonna get back to the problem that you have with the monolith approach, or maybe it getting worse. So secondly, to keep your build time as good as it can, then you have to your module should be as independency as possible. In the C here, I mean that okay, your module have less dependencies, or your module should depend on abstraction instead of some implementation. For that, I want to give a simple example for using abstraction. let's say I have two modules, module A and module B. Module A have feature A's and module B have feature B's. Now module C need to use some feature A and feature B's. It look like the image. So what is the problem here? First, let's say when you hit the build button, then module C have to wait module A and module B being built before building module C. Secondly, let's say now you have two teams. One team is working on module A, the other team is working on module C. Maybe some conflict could happen because someone change something in module A will directly affect module C. That's the problem. So what is the solution? I bring here a simple solution that we can use. We create an interface module. Interface module gonna create interface A and interface B stand for the future A and future B. And now I let module A and module B use the interface module. Not use implement the interface module, like module A gonna implement interface A, module B will implement interface B. And now module C can use the interface in interface module for module C can use the interface like interface A and interface B in interface modules. And the last thing, application will provide implementation for module C. And now what do we have? Though module A, module B, and module C have no idea about the other. It means that now when you hit the build button, then module A, module B, and module C can be built in parallel. That's the first thing. The second thing, if you have multiple team or multiple devs working in different features, then module A and module C can work in parallel. Will not break the other logic. It somehow will speed up your development time. So to keep your module independent, you have to always like in our team to keep your module independent. You have to always think about it. It forces you to decouple the code between modules to keep it independent. Doing that, we have to rely a lot on interface and abstraction, which will be a good thing for your project. Like it will reduce code and future colliding or coupling. Also, you're gonna have a cleaner code base or architecture. Or if your module is independent enough, then you can use the module in the other project, or maybe you can bring it out like another project. All I want to say here that now multiple teams are that can work in parallel. It will speed up your development. Here is something that that we have now, like in our project. We have some main modules which we like are not depend on each other. So now we can work on the future in parallel. We have some abstraction modules and we have some common module which is being shared between between the modules. We also have some library can be bring out to you in the other project. That are what we having now. Okay, so now we move to experience sharing. That's something we've done that I have to say give some time. First is about the visualization. Visualize to let's say now your team have the number of Gradle modules gonna like increasing. Let's say you have 30, 50 Gradle modules, and someone to do some small change. It will like maybe double your build time or some problem. So now you should have a visualized way to look at your dependencies. You cannot go to every Gradle file to check your dependencies. So we write some script to generate a dependency graph. And I already put in the example project that I've been showing. I showed you before. It's just some Python script. It will generate you the dependency graph and when I open it by a YED program, you can see it look like this. So now you have a visualized way to see, okay, how your dependency tree is, and from that you can investigate to see which one you can break, or which one you should not have dependencies, and you will have a visualize. Okay, maybe you know what costs the time for you to do the build, and so on. Get back to the building process phases. There are two things that I think we can do here. First is the phase that we are Gradle processing your resource and manifest. In this phase, if you have, you can create some pure Java or Kotlin modules. You know, when you create a new Gradle module, and you have an option that you choose whether it's a Android module, or you can choose like a pure Java and Kotlin module. So when you hit the build button, the second phrase it will be ignored. So somehow it can save you some time. The second thing is about annotation processing. Many of you might know, like when you use annotation processing in your Gradle modules, it will break your incremental builds, or Java incremental build. So now you can have a workaround by move all of the class that have annotation processing to a Gradle module, and move the other class which don't have annotation processing to another module. So now if you change something in like non-annotation processing Gradle module, then when you hit the build button, you still can use Java incremental build. The next one that I want to say is you should not let many Gradle module depend on one like big module. For example, here I have the rate of project. Like the rate of the project have to depend on module 14. They say when you hit the build button, then only for module 14 being built at first. So there are no parallel buildings, and so you should not let you should not let many Gradle module depend on one last module. Otherwise, it may not good for your build. And the app module, you know that whenever you do any change in your project, like in the lead module or any module, then the app module will always be built. It's always be built for incremental build. So make sure that you keep the app module as light as possible. It will be very good for your incremental build. More thing that if you have a frequently update module, you have a large module depend on a frequently update modules, and you may consider to add an interface module in between to reduce the incremental build time. Because now, like when you update in the update frequently module, then it will not fire the review in last module in this example. The next thing is how do you measure the dependencies more effectively with your with your build time? To doing that, you first you should set the worker to one. It means that only one single worker will being used to build your project, and you get the build time. And then you gonna let that number divide to the number of workers that you have. Then you will have an ideal build time. And now you can use your normal build time that you have to compare with the idle build times. So the closer one and your build dependency is like more effective. One more thing, otherwise maybe some of your Gradle module will be stable enough. You will not change it anymore, or if not being changed, or so it's stable. I mean, So you can export it to an AAR file or YAR file, and you might import to your project, or you can publish it to a binary repository manager like Artifactory or G4 Artifactory. Then it will be also save your time because it can use .existing view file. The next thing is about Dagger tools. If you are using Dagger tools and now you have multiple Gradle modules, so somehow in your usually you can use the plus method to grade another, like to grade the sub component. But now because you have multiple Gradle modules, you cannot access to the parent component. The solution is you can use component builder. I think it's quite common, many of you may know. Or you can use Dagger Android bucket. And one more thing, I think you should do that. You should use dependency component if possible. I mean, because the point that I bring before that we should keep your Gradle module as independency as possible. So in Dagger, you have two relationship between two components. One is subcomponent, second is dependency component. Dependency component usually give you the more opportunity for independent. So you should use it if possible. One is about program. Let's say now you have multiple Gradle modules. If you have only one program file for your project, maybe it's not a good approach. So so for our approach, we put every Gradle module going to have a program file rule, and being configured by using consumer program files configuration. The last one, sometimes when you are adding or removing Gradle module in your project, and you might face some very rare building issues. I think it's mostly because of the annotation processing. So for the case, you might try to link your build cache by the command, then it may have issues on you. I think that's all. I hope you have any questions.
Okay. For your experience, how you split the modules in your case? This is like a fragment-based, activity-based, functionality-based?
Usually it depends. First, I think if you want to, first you should consider to bring out something independent, for example, curtain views, and then later you move on to some specific feature, and maybe depend on the kind of class. For example, is the API file or repository, then you can group them in some specific. Actually, it depends on your need.
You said a bit about how you start to modularize an existing project.
Actually, for our project, we start from scratch. But for your question, my advice, you should start with something, as I say, independent. For example, a custom views, or something you think that is not, how can I say, is not a big thing that have many relationship with the other part of your project. Something independent, you can start from those things.
If we has many modules in a project, I think it's difficult for maintenance and something.
Actually, it's great. Not maintenance, but I think we also face some problems. Let's say now we have multiple teams working in parallel, and sometimes someone just put some dependencies somehow incorrectly. So sometimes the build time is break, like sometimes it's double time because of some change. But I think it's a good practice to follow is divide to conquer. So so far we are happy with this approach. Thank you for it.
In your Droid project, so how did you define the module? I mean, how big can be a module, like a login feature or the user feature analysis?
For my project, currently we have, as I say, we have some big future, like some future we can bring out like modules, or some we can get back to the slide. Here is the group of modules that we have. Actually, we try not to have a big Gradle modules. Let's say if that module is that feature is big, and we try to separate to smaller one. Because first is affect to your view times. Secondly, one last one is not the target of multi-Gradle, like the defining. So we are trying to not to have a very large Gradle module. Even if that feature only one feature, but if it's getting large, we also trying to separate it to some small one.
Thank you very much for the presentation. Are you going to share the slides?
Yes, if possible. Do you know where can I share this slide?
Twitter. Twitter. Put it on
Okay.
speaker name.
Okay. Any more questions?
You have mentioned about abstract module and base module.
Actually, it's more like abstract module. I mean, it contains interface and some abstraction. In programming, whenever we mention about abstraction, maybe like mostly we talking about interface. Actually, abstraction I'm talking here like maybe some mostly we put interface in those. Okay, there are no more questions, and thank you very much for joining today.